Welcome to Life Edge, because life just doesn't have to be mediocre. I'm Rick Zanotti, and I'm joined today by my good friend, coming to us. Are you in Oklahoma today?
I was in the same place, Oklahoma.
Same place. So Dr. Susan Nash joining us, and we also have with us Harold Muliati on the video switcher and mixer, and we've got a great guest for you today. Here we go.
This show is sponsored by Relay Corporation, digital learning development, media development, corporate video, management consulting, and more. Visit us at www.relate.com. Thanks.
And we are back. Susan, would you like to do the honors?
I'm thrilled to. So we have a great guest today. We have Robert Gibson, and he's here to talk to us about machine learning and different aspects of its utility in the oil and gas industry. But more than anything, I'm really excited about how he has some ideas about how it can be used in many other industries to solve some potentially upcoming issues that we could be facing. So welcome, Rob.
Well, thanks for having me. It's my pleasure to join you both today.
No, our pleasure having you.
Yes.
So
tell us a little bit about what you do at TGS.
I will do that. It's going to be an interesting challenge in these current environments where, 900 million people are all on the internet at the same time trying to have video conferences. So we'll see how long this lasts as far as my connection goes. But yeah, my name is Rob Gibson, and I am responsible for the analytics products at TGS. TGS is most known as a seismic company, and I've worked most of my career at TGS on the well data products. So it's kind of a complementary product for TGS to the seismic data. So my responsibility is to talk to our clients and find all the different ways that they use data from us, from other vendors, and use our analytics, our machine learning, our data science capabilities to try to help those workflows using our data and using our own data as well. So we have a very large data lake of information, and it's really about how we can take all that information, wrap it up in new ways for our clients to use.
Well, that's very interesting. Some of the examples that you've shown in the past have to do with the predictive abilities of machine learning. So I wonder if you could show us a few ways that it predicts, say, rock properties, like from between one well and the other.
Sure. Yeah, I've got a couple slides, the first few slides in my slide deck on that. What we're trying to show in this picture is, if you back up just a second in the storyline, when you drill a well, you run a tool down the well to give you information about what's going on, what kind of rocks there are, how the rocks are going to behave, whether or not there's oil and gas, those kind of things. And these curves in particular, especially as you look at the left-hand section, they've run a lot of these tools. So you can start to see the development of the film, if you will, the pictures kind of coming to light. But the problem is these tools are very expensive to run. They don't always need them in an individual well. So when you look across this cross-section, this slice out of the earth, there's a lot of gaps. So if you move to the next slide, what we've done is we've taken all the data that we've got in the region, and we're able to now fill in the picture. So if you want to think about this as like, there's a classic machine learning problem using images of a orca whale jumping out of the water. And imagine taking that photo with a really old camera. It's very grainy. There's droplets of water in the air, but you want to find out, is that an orca whale or is it some other kind of whale? And as you slowly focus that camera, you can use machine learning to remove the noise. And we've done some of that with our data, but more importantly, to predict where the actual data is. And in some of these cases, what these red and blue stripes, horizontal stripes in the data represent, are different layers of Earth, where one red layer might be oil and gas, the blue layer below it might be rock where you get nothing. So what we're trying to do is we're trying to take a very, very raw image and predict and infill the information so that we can understand what the subsurface really holds. And that's what those two images are trying to represent.
So, Rob, in machine learning, is it still all about pattern recognition?
Well, there's so many different kinds of AI. There is a lot of pattern recognition here as well. What we're doing is, this is a binary trees problem that we're working with. It's not using images themselves. It's actually taking multivariates and multiple variables and seeing how they correlate from one well nearby to another one nearby. And in theory, you could actually say, there's no well right here where I'm looking today, but if I drilled one, what might it look like?
Okay.
So we might actually be able to give operators the ability to understand what the subsurface might hold before they ever touch a drill bit to the ground. So it could save them time, save them money, save the environment, and give them a better picture of what's going on before they actually drill a really expensive well and find nothing.
So people would use these tools really, like Susan was saying, as more of a predictive tool. You can analyze where you want to drill, analyze proximity to other wells to get an idea of, will this be a good well? Will it not be? Any issues with the ground? You mentioned seismic. Are you also looking for the possibilities of seismic activity where you're drilling?
With this particular data set, we're not. It's not that you can't do that. It's that usually with seismic, and if you don't have recorders on the Earth, then you can't record the event. And so with seismic activity, it's so irregular and highly unpredictable. You really need to lay out a grid of either hydrophones or geophones so that you can make a noise and then record it. So it's a little bit trickier than that, because you can't leave those sensors around the whole time. We do, however, use the seismic data that we have in the area to use that as a constraint or a controlling variable to make sure that the responses we see in this data make sense with other data sets.
Nice. Okay.
That's super cool. Well, so in addition, I think it's exciting that. Oh, go ahead.
All I was going to say is that it's interesting because typically the people who are using the well logs, the recordings that you put down the hole in the ground to take the readings, those people are usually petrophysicists, geologists, the people who are trying to understand what's going on right there. Well logs weren't typically consumed by geophysicists and engineers and financial people. That's really where this data set's now kind of opened up a new market. These are people who are trying to understand the economics of the field. And so they want to understand on a large scale, not very, very narrow, but on a very large scale, if something's going to be economical, viable, something that's worth investing in.
I really like that because it gives you a chance to run different scenarios and very quickly come up with a range of values.
Yeah, it's really expensive. If you think about buying land, some places in the U.S. you can buy land for $1,000 an acre. Some places it's $100,000 an acre, and it's all about the location. When it comes to oil and gas exploration, it's no different. What you need to do is you need to grade the acreage, and if you can give it a grade of an A+ versus a D-, then you want to go after the A+ acreage. And especially if you've got an edge over your competition, and you can get in there for $1,000 an acre before they realize the value of it, and it goes to $100,000 an acre. Now you've got a competitive advantage over everybody else. Or if you're a financial investor, private equity, A&D groups within oil and gas companies, it gives them the edge over their competition. It's pretty fascinating.
I really like the way it can be applied to all sorts of things. I was thinking today we found out that in New York City, after they did random testing of COVID-19 and coronavirus, they found that like 20%, they think, of the people have been infected, but it's basically through extrapolation and pattern recognition. How could your algorithms be used for something like that, for like predicting and analyzing the extent of infection?
Well, before I answer that, and I will get to it, we've actually not invented anything unique here. we're taking learnings of Facebook, Microsoft, LinkedIn, Google, Tesla, Uber. We're taking those and we're applying those technologies to oil and gas. Those technologies are very transferable into those medical type things. For example, oil and gas is notorious for having a lot of handwritten and paper documents. Think HIPAA in the world of medical. There's a lot of paper documents. When you go into your doctor's office, I'd say a majority of doctor's offices require you to fill out paper. All that information needs to become digital so that that information can be leveraged and used by groups like the CDC in order to more quickly identify what's going on in cases like a pandemic. To answer your direct question, though, Susan, I saw that Google and others are starting to invest in cell phone proximity. You can use similar machine learning and AI techniques to understand if my cell phone is moving from my house and I'm starting to move into a hotspot of COVID virus activity, it has the capability of warning me and letting me know that, hey, you need to take some extra precautions, or don't go there, or whatever else might be going on that the government has imposed in that region that I might need to be aware of, much like a flood warning or a tornado warning. So I think that as we continue to use this kind of technology, there's nothing different about using it in a world of medicine, such that you could take some of that personal information, which we're all really wanting to hold on to, and anonymize it to the point where we could use it on a grand scale. If I was willing to say, I have COVID-19, don't come near me, and my cell phone, which is by my side every single minute of the day, let people know, well, that's kind of the extreme of it. But if you can anonymize that and do it more generically for the population, this kind of technology can be used to help you do exactly that.
Yeah, that could be scary. We could come up with a whole India class of untouchables. COVID, get away from them. That could be scary.
But that's good if someone wants to break into your house. I've heard a big thing. Infected, don't break in here.
It's a crime deterrent. I get it. That's funny.
No, it's pretty interesting what you can do with the technology, because a lot of people think that AI is to replace people for making all sorts of general decisions. And that's not where we're at. And it's hard for us today to foresee a time in the next, 50, 100 years where general artificial intelligence is going to come into play. What we're trying to do is we're trying to solve very, very specific problems. And we're trying to use artificial intelligence, machine learning, neural networks, whatever you want to use, to help us understand either the computational complexity of it or the pattern recognition of it that we just wouldn't see, to come to a conclusion either faster, better, cheaper, whatever the case may be. And that's really what the problem is we're trying to solve with that image I just showed.
Now, Rob, do you think the programming language technology is there to really take AI at this moment to the next level, or are we still developing that? I mean, I remember back in the 70s and more 80s taking some artificial intelligence languages like Forth, Lisp, Prolog, and I took classes in those, and it was really fascinating, but it didn't do that much back then. It was fairly limited. Now we're doing things in AI with JavaScript, and you go, wow, that works, and it's working pretty well. Do you think we're at the level yet of taking it further?
I think we're kind of still in the beginning. I won't say it's completely nascent, but we're definitely early in the process. Okay. When I started programming at Lockheed, I had to, if you look at your computer monitor and you see, a Word or Excel document, in the upper right-hand corner, there's a little X that says close this window. Mm-hmm. Back in the early 90s, late 80s, you had to program that. You had to draw that X yourself. Yeah. And when you click on it, you had to say, okay, here's all the actions I need to take. Now it's just part of the language. You just say, open the upper window. You don't have to build the entire thing. And that's kind of where I feel like we are with Python and some others. It's a great scripting language, and it really gets a lot of stuff done. That's awesome. Now, to operationalize that and to take it to scale, there's still some work that needs to be done in that area. But to get a problem done by a data scientist, it's fantastic. Yep. To get big problems done by an army of data scientists, I still think you can do it. It's just going to be a little bit more work now than it will be 5 years from now.
And then the second thing would be the database technology. we're still pretty one-dimensional with a lot of the databases. There are some three-dimensional database models out there, but I worked on some years ago, but they weren't, even in those days, 64-bit or higher. So they were limited in the size of data that they could store. Do you think are we getting there in the database stuff, or is it still pretty much the same where we're just doing workarounds to figure out how to store enormous amounts of data?
It's interesting to that point, because I feel like that's an education problem at this stage. If you ask me to go build you a database, I guarantee you it's going to be a relational database,
yes,
old school.
Yep.
Because it's what I know, it's what I did.
Yeah.
I can do it a lot better and faster than I could back in the day, but it's still just a relational database.
Mm-hmm.
Now, if you go to somebody who just came out of university, has got 3 or 4 years of data science and DBA under their belt and that kind of stuff, I guarantee you they're moving toward NoSQL databases and cloud hosted faster than we could ever imagine.
Yeah.
And for our data lake at TGS, it is cloud hosted at AWS. It is not Microsoft or Oracle or the big names of the past. It is all these very unstructured, very fast online databases. It's pretty interesting how the technology's changed. And you got to give some credit to those guys in Silicon Valley who've been doing the Facebook and Google type stuff for a while now, because they really were pioneers in getting the technology to where it's at today.
Yeah, and it's incredibly fast. My wife used to work at a company called Teradata. They were the very first company to come out with a Teradata, or a terabyte machine that could actually store 1 terabyte, which in those days was about the size of about a 5,000 square foot room with a lot of platters all around the room, hundreds and hundreds of them. And that was 1 terabyte. Now in about the size of your thumb, you could have a terabyte. And it's just amazing. That was, let's see, that was 1986, I think, when she was working there. Think about it. It's not that many years ago, 36 years ago. And now, wow, have we gone way past Teradata and all of that. Now they're just a data warehouse. And I say just in those days, it was like the most advanced technology out there to store data. Surprisingly, they could retrieve a set of information, billions of records, in 1 second, but they couldn't retrieve one record many times in under a minute. It took so long because they were set around a set theory that was very different from your normal interactive database. They were much better at reporting stuff. And guess who their main clients were? AT&T, Walmart, who needed that information quickly to be able to massage purchasing requirements and everything else. What do we have to build? How do we build it? How many do we need? How do we forecast? Finite forward forecasting and everything else. It was really interesting, but I think we've come a long way since then with the hardware capabilities. So you're probably, especially in what you do, you're seeing some incredible hardware capabilities with the software catching up, right?
Yeah, I mean, think about autonomous vehicles.
Yeah.
We've been driving autonomous vehicles now for 6 years or something. And we've got millions and hundreds of millions of miles, and we're still proving out that technology. But you've got to think about the compute capacity. We're sitting with a GPU card or multiple on board a car that's not running in a huge data center that doesn't weigh 14,000 pounds. This is something that can actively tell you that that's a bicycle versus a motorcycle versus a cat, and can react accordingly. It's pretty fascinating what the technology can do in a very, very small space.
Yeah.
So I have a question. Okay. So I had an interesting conversation this morning with some teammates. One was in Norway, and the other was in UK. And we were talking about the future of investing over the next 18 months in this pandemic and hopefully post-pandemic world. And we were coming to it's clear, I think, that there will be enormous investment in factories and manufacturing for local supply, and that the supply chains will have more redundancy. So there will be that, and that it's a strategy of import substitution, but it's also to make the supply chains more robust. And I was wondering how, say, TGS or what you do there how that kind of fits in supply chain.
Well, it's interesting because supply chain in the U.S. has been so focused on just-in-time inventory for so long, and we've moved so far from a manufacturing economy to a service-based economy that we've put a lot of reliance on that supply chain, global supply chain. And I think what we're going to see out of this is that there's going to be a little bit more hedging. I think it could certainly help local manufacturing globally, if that makes sense. Where you're going to have some of that, capability, the core capability existing back in the U.S. when it may not have existed anywhere but somewhere else in the past. And the thing about the oil and gas industry is it has the same kind of supply chain as what Walmart and others have, and it's got the same kind of dollars behind it. If you think about what happens in oil and gas transportation, for example, you've got to move water, sand, oil, gas, build pipelines, people, fly people to and from platforms and boats. The supply chain in oil and gas is absolutely fantastic. And I think you can see that the oil and gas industry can help because it's not as just in time as what Walmart needs for rolls of toilet paper and hand sanitizer. I think it's a little bit more physical because there's a lot more physical things that have to move in our industry. I have a pretty good feeling that we're not going to be reliant upon another country to produce surgical masks, N95 masks, face guards, the personal protective equipment, and that kind of stuff as we were even 3 months ago going forward. So, whether or not the artificial intelligence that we're working on at TGS has a role in that supply chain, I don't know, but I do know that the artificial intelligence knowledge is transferable. Whether or not you use it in supply chain at TGS, supply chain at Walmart, or supply chain somewhere else, it's still supply chain and it's still artificial intelligence that can help you figure out where you've got product, where you need product, and the best way to get it there to find that pattern, to recognize it, and to make it aware to all of us so we can act on it.
Yeah, and the biggest thing we've done wrong with supply chain is we didn't distribute it. We kept it single sourced or almost entirely single sourced with no thought about fault redundancy or anything else. And sure, let's just go in one place. Well, that was brilliant. By the way, I've been arguing about that for years. Why are we doing this? It makes no sense. I used to write supply chain software, management software, and it was going, this doesn't make sense. Like you said, having a supply chain, the software can figure out where everything is, but having it only in one place doesn't stress the software that much, but also makes it very prone to exactly what's going on now, where one country, for example, is doing the majority of the hoarding of resources, and you go, that doesn't make a lot of sense. And then everybody's a victim to that. We're now paying either more or having to negotiate badly to get things we may want because we don't have them because we didn't think ahead. So it's just an interesting aside of what we've done and how we got there. And like they're saying, it's not that we're not making profits. We're making maybe too many profits because we could build the same things. Maybe it would cost a little bit more here or in other countries. But in the long run, think of what we're saving from what's happening now. I mean, we should touch upon this just for momentarily. We're in a very incredible time right now in terms of oil. And people, of course, there's a lot of people out there with absolutely zero brains who are going, it's so great, the oil industry's dying. Yes, now we're going to get all these natural things. No. And they don't think that half the plastics or all the plastics in the world don't come from oil and everything else. And they're like, huh, what? Oil? Really? It means something? So all these people cheering have no clue what world they're living in at all.
It's a balancing act.
Yeah.
Because it's not exactly the sexy industry that Silicon Valley might be to somebody coming out of university, for example. But it's an absolutely essential industry to live the lives that we have built for ourselves.
Yeah.
And, these glasses wouldn't be here without those products. These headphones that I use to listen and participate in this conversation wouldn't be there. That microphone. There's so many things that just wouldn't exist, not to mention how we communicate and how we move around the planet. I like to travel. I really enjoy traveling. And I can't do that if we don't continue to find ways to move from point A to point B efficiently. And
Yeah.
don't get me wrong, I don't like just traveling from my house to my grocery store. I like to go overseas too, and I'd like to do that in some reasonable amount of time.
It's so true, and so it's interesting for a lot of people now starting to figure it out. They're going, I didn't realize that this affect. No, you didn't realize anything because you don't think. You're not trained in this. You don't know anything about science or anything else for that matter. And you just kind of shake your head and go, okay. And unfortunately, some of these people are making decisions, but that's another issue. But it is amazing how this is the first time in history oil's gone, I think, at a negative value. And everybody's just going, they're using the pipelines now to store oil because they have no place to put it. It's everywhere. It's just amazing. And we were talking a little bit pre-show with Rod about how, we wind up in this kind of semi-oil price war with Russia and Saudi Arabia, and they've screwed themselves over more than us by what they've done because they need more money to even benefit from more than we do. I think the Saudis need $80 per barrel to even break even. I think we need 50 if I remember correctly, or 60. I don't remember. I think the Russians weren't far behind us. So we're all in a mess with oil now, and I'm sure it's not going to last long. But they're saying the futures industry is tricky because now people don't know what to do with contracts that are in place, other things that happen. What do you guys think is going to happen with oil per se?
Well, I think we've certainly got a long-term rocky road ahead of us.
Yeah.
We've been overproducing for a while now.
Yeah.
The fact that Russia and Saudi, and OPEC plus, the fact that they got into that little tiff and they decided they were going to increase production again, and then the virus coming, which is basically keeping everybody at home and reducing the need for oil. It's like this self-fulfilling prophecy. And, I saw a headline the other day that the one big thing that cures low oil prices is low oil prices.
Yeah.
It's going to have an effect on the industry. And I don't know that we necessarily see what that entire effect is, but it is going to cause bankruptcies. It is going to cause layoffs. It is going to cause a change in the way we do our work for a while. And anybody who says that it's only 2 or 3 months, I believe is definitely fooling themselves.
Yeah.
This is something that could go on for quite a long time.
Well, do you remember
and the last one started in 2014, and it took 3+ years before we saw any kind of bounce back at all.
And I remember one of the main oil crises we had, I think it was 1988, 89, right around there, where people were leaving Texas in droves. There were no jobs. Jobs just died out, and engineers were working as anything they could find jobs. And back in those days, geologists couldn't get jobs. And that was back in the 80s, late 80s. That's not that long ago. And just yesterday, I was reading an article that said there could be as many as 4 million people laid off in the oil. 4 million people in the oil industry again. And you just kind of shake your head and go, wow, it's just insane. Susan, have you heard anything about that, especially with APG and everything else?
Yes.
Yeah.
It's terrible. I mean, it's just absolute carnage. And there's so much uncertainty. I think that essentially what we need to do, we're putting together a toolkit for people to equip themselves. But in the late 80s, I'm a survivor of that. I had the opportunity to diversify. And so I studied economics and also went on master's in economics and a PhD in literature, focusing on apocalyptic narratives. It's the gift that keeps on giving. But what I see is that if we're not careful, we need to all band together now to make sure that the crops are planted, that crops are harvested, that crops are processed, and we need to be innovative. And if people are getting sick at the 9 or 10 mega plants, then we need to find out ways to get them safe and get more people, because there's going to be a global famine that they're predicting already, and we need to band together and do everything we can to safeguard food security.
Well, they were saying right now there's 30 million people probably dying from famine at the moment in the third world, just as a result of what's been going on here and other places. But nobody talks much about that. But you're right, this is going to affect everybody a lot more.
We need to come together.
Yeah. Yeah. So what's happening is we're talking a lot about the oil problems here in the U.S. What about other countries? How are they? Have you heard anything about other countries and how they're coping with this glut right now? Because nobody's driving to work, nobody's doing anything. They're not cooking in place. Nothing's using up our fuel. What's going on in other parts of the world?
Well, it's definitely the same thing that's happening here in the sense that we've got an oversupply, we've got an under demand, and there's a lot of ways where you can typically try to help that. You can slow production. You can restock the petroleum reserves at the governmental levels, but at some point you just run out. If there's not the demand and you've got too much supply, it's kind of like the economic problem right now. You've got a supply and demand problem, and you can't just balance one side of it, drop the interest rates to zero, and everything's fine.
No.
That's not where this is at. What we're looking at is a whole new world, not just oil and gas, but a whole new world over the next, 18 months, and it starts right now. And I don't even think that we've got a good sense of what it's going to be like. I mean, Susan's right. If we do see these kind of things happening in world famine and supply chain, and the food supply, farmers going under, they can't produce crops. It's going to be interesting to see. It's an opportunity, but it's an opportunity that we're going to have to approach more holistically than just from we're going to make more money in oil and gas. This is going to have to be more of a humanitarian approach where everybody is on the same page at the same time, moving things forward.
I agree. And speaking of what other countries are doing, I know I've been in touch with other countries in terms of oil industry. They're getting laid off or not working. In terms of food and supply, etc., there, for example, in Trinidad, where he's like, well, we're an island, we're running out of food. Chile, they don't have oil production, but they have minerals. Difficulties, things. In terms of the oil industry downturn, many countries have national oil companies, and they use the proceeds for social programs and medical, school, and they are just going to be eviscerated. And that's very terrifying.
Yeah.
That's a really good point. And even companies like ours, when we go into a country, especially countries that aren't, more rich countries, but if you think like Western Africa, for example, we have to invest in those countries, not just go in and acquire data and drill wells, but we have to invest by law and just by ethics. They need education. We need their workforce. And without the two things working together, it just doesn't work at all. So without companies going in to do those kind of investments, or like Susan was saying, the countries where the only thing they have is a national oil company, if they're continuing not to invest and they don't have a product to take to market, then it does have an incredibly damaging effect for a very long time on their people and on their economy.
Yeah. I can imagine Mexico right now is having a hard time because they have Pemex, which is their major oil company, and they were pretty cheap before on the oil, and I can imagine what it's doing to them right now, as one example, and there's a lot.
Another thing we have to keep in mind is the impact of this on China. China, for the last 10 years, has been investing heavily in the Belt and Road Initiative, in that they provide infrastructure in exchange for often the primary product of the country. So it could be oil or it could be minerals. But then they also have been using that as kind of a Marshall Plan to employ Chinese workers, and they bring the workers, and they also actually export the cement, the concrete, etc. And then they also open it up to Chinese tourists. So, for example, Zimbabwe and Victoria Falls, new airports, etc. So what that has done is it has had a stimulus effect in Africa and it's also had some other effects. But if you take that out of the mix, if China can no longer afford to have its presence in Africa, you're going to see a balloon just go.
Well, also, Susan, the Chinese economy is fragile. It's not strong. And, there's a lot of, conspiracy theories that they launched this as a bio attack, blah, blah, blah. Maybe. But the thing is, if they did, then they're really stupid because they've just knocked out the one country that buys the most from them. And that's the U.S. Without the U.S., that is the world's largest buying market, bar none. Not even close. Nobody even comes close. So as a result, if this was, quote unquote, an attack, then it wasn't really well thought out, was it? Because right now they're not selling anywhere like they used to because there's not a lot of demand for some of the products that they make. I would assume companies like Apple right now are going, look, we've just released a new iPhone, and people are going, yeah, good luck. I can't buy it anymore. I don't have the money, or I don't have this, and so I don't know if everybody's either tone deaf or we've just gone nuts or what the reality is. Nobody really has a whole 100% clue on it, but it is interesting how if they did plan this, very incredible planning, because take us and themselves out? It doesn't make sense.
No, that would be like Jim Jones.
Well, there's a lot of those around, but you never know. Yeah, you wouldn't think so, but anything's possible.
I don't think so. I think my personal conspiracy theory is that if it actually...
Oh, did we get knocked out?
Oh.
You cut out over there, Susan.
You cut out just before you...
Just after you said my personal... controversial, I get cut out.
Yeah, you said my personal conspiracy and you got cut out.
It's not an accident.
You never know.
Well, I think that an eco-terrorist did it because there's all this gloating about, wow, look how great the planet looks now.
I know, which is stupid. As they're sipping their cappuccinos, going, isn't this wonderful? You won't have cappuccino soon. Won't be able to get beans. Yeah, interesting. But you're probably right. Wouldn't surprise me. I remember in California we had all the eco nuts blowing up. What was the car at the time? Oh, the Hummers. They were blowing up Hummers everywhere. Not Hummers. It was it Hummer? Yeah, I think so.
Well,
so, yeah.
I don't believe it. I was just trying to make some dumb joke, but I don't really believe it. I think it was an accident of nature. I think if we're not careful, we can create another one by noodling. Because you think about it, you stick your hand into dirty water, it has goose poo, it has avian flu virus. You grab the catfish, it scratches you, and who knows what you're going to create.
That's probably true. Anyway,
it's not the last time we're going to see something like this, that's for sure. It's hopefully we'll be smarter about how we address it next time.
Yeah. Well, we are just about out of time. Rob, we'd love to have you come back on again and talk a little bit more about what you're doing and where that technology is going. It's pretty fascinating.
I do feel blessed. I do feel blessed to be involved in a company that's got the volume of data that can actually let data scientists be able to do what they're doing. Yeah. Without a lot of data and high quality, you can't really put together something that you can have high confidence in. So I do feel blessed and just as blessed to be a part of the show, and I do look forward to coming back soon.
Great, appreciate it, and we love having you on, and it's been really fascinating. I'm glad we could meet you, and I know Susan knows you, but I feel this is great. So thanks for coming on again. If you have any questions and you're watching the show, please put them in the show comments below, and we'll try to get answers to you. Also, we'll have information on what Rob does and links to websites and stuff below. So thanks for watching, and stay safe, and we will see you next week on Life Edge. Have a good one, everyone. Thanks. Bye-bye. Thanks.
Thank you, Rob.
My pleasure.
Bye.